Welcome back to Bernoulli's principle. I had like two things to say before I got cut off. And so, what we find is that in real life, things are going uphill and downhill and changing velocity all the time in our practical applications. So whether we're talking about, veins and arteries and capillaries, or we're talking about river or water pipes or whatever the case may be, things are always changing direction and changing flow rate. But Bernoulli's principle tells us a lot about that issue in that the initial pressure, kinetic energy, and potential energy will be equal to the final pressure, kinetic energy, and potential energy. When you expand this formula down, it can look really hairy and very scary, but I'm here to tell you it's not so bad. And so you get the initial pressure plus, and then this is like the kinetic energy formula, it's 1/2 the density times the velocity squared, okay? We've been using these variables p and v for a lot of things. Please try not to get them confused. One of the things that I do is I put a little hash mark across the density p, so I know that it's not the pressure p. And I'll usually put a little vector over velocity as well. And so we get that kinetic energy plus, and then again the density of the liquid times gravity times its position along the y-axis is equal to pressure, blah, 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 and then same thing for the end. And so given this formula, we can find a lot of different things. I will usually give you the density of the liquid. Obviously, you know gravity, and I'll usually give you the height. What I'm mostly concerned about here is the velocity. And so when city planners put these kinds of things together, they can get the velocity of the big thing along Main Street, and then they can calculate the height of a hill and the velocity that that fluid will need to overcome gravity without a pump, and they can design the pipes to do that so that they increase the velocity as they go uphill and increase it as we go into people's houses. And so that's a great application of Bernoulli's principle. Alright, and because this is such a big hairy formula, I want you to just try your best and give number 33 a go. And 33 is referring to that picture on the left, 13.33. And please note that that liquid is oil that it's talking about. Alright guys, best of luck. See you in 13.7 video.